then we are going to start off the class. So I have this notebook with me here, which explains what hyperparameter tuning is and model validation. So I'll zoom in, then we can go through it, and as I explain some parts that we have here. Okay. So hope that's visible and you can see my screen. So here we have hyperparameters and model validation. Okay, so we've learned some things on how we can reprocess our data and make it ready for model fitting, how we can create our model and how we can fit it to the data. So with that way, we can come down to this part. So here we have like the first way of creating models. So, pardon. So first of all, we import the dataset that we are going to use. Then we load the data. Then we create our X and Y values. So after creating our X and Y values, we decide which model we want to fit. So for example, for this task, it's a classification task because we have our target variable. And having our target variable, we can fit a KNN model. And for KNN, we have a hyperparameter known as the number of neighbors. Okay. So after importing and instantiating our model, what we can do next is we can fit the model to our data. And after doing that, we can check the accuracy. But what you should note is the accuracy is at 1. So is this accuracy of 1 correct, or is it something that we can question? Okay, just a minute. I'll have to take this call. import here. So if we run now course.mean, we get a mean of 0.96. So the model is 96% accurate. So that's all about cross-validation. So you have to import your model, instantiate the model, then specify your X and Y, so your features and target. Then after doing that, import cross-val score, then fit cross-val score. So to your model, your features and your target variable, then you can get the mean of your folds, and that will be the average performance of your model. So let's proceed on to the next thing, which is grid search CV. So grid search CV is used for hyperparameter tuning, and we will use logistic regression for the hyperparameter tuning part. So I decided we should look at the sklearn documentation, and I will also refer you to the sklearn website documentation for your research on hyperparameters, because these models have lots of hyperparameters and we cannot discuss all of them in detail. Okay, so here we have maybe, for example, the logistic regression model. So if you check here, we have the parameters. And for the parameters, we have, for example, for the logistic regression model, we have penalty. So it has the L1, L2, elastic net, and none parameters for penalty. So none, no penalty is added. L2 adds an L2 penalty term, and it is the default choice. L1 adds an L1 penalty term. Elastic net, both L1 and L2 penalty terms are added. So you can see here we have lots of hyperparameters, and if we said we were to discuss them all, then it will take us a lot of time because we have already discussed some. And the reason as to why I'm showing you this is because you can see, for example, for logistic regression, we have the penalty hyperparameter, we have the dual hyperparameter, we have the toll, we have the C, we have the fit intercept, we have the intercept scaling, we have the class weight, random state solver, and basically we can't discuss all of them. So you can see we have max liter, multi-class, verbose, warm start, n jobs, L1 ratio. So all of them. And remember, we also have models like decision trees, which have even more hyperparameters. So what I will suggest is, if you want to learn more about them, you should visit these sklearn website and open each and every individual model and take your time and see the hyperparameters that each model has. So for today, for logistic regression, we will look at the C hyperparameter. So the C hyperparameter is the inverse of regularization strength. So must be a positive value float. Like in support vector machine, smaller values specify stronger regularization. So regularization is just like when you are scaling values. So what you do is you
Joseph,
scale
good
them to
evening.
like be in a smaller range,
For that,
something like that.
all
So
these
let's
20
discuss
different
what we have here in
models,
our notebook. So in grid search CV
they
approach, machine
from
learning
the
model is
same
evaluated for
data,
a range of
or
hyperparameter values. So
so which
the
means we
approach
have
is called
20
grid search
different
CV because
splits,
it
right?
searches for the
Random
best set of
splits, or
hyperparameters from a grid of
not
hyperparameter
random
values. So
splits.
for example, if you check this, we have the C hyperparameter and we have the alpha hyperparameter.
Yes.
So for example, for the C hyperparameter, we can specify like a range of values from 0.1 to 0.5. And for alpha, we can specify from 0.1 to 0.4. And here we will have like, so these are 1, 2, 3, 4, 5,
Yeah.
1, 2, 3, 4.
I think
So here
maybe
we will
I'll
have 20
practically when
different
we do it, I
models
think
being
I'll be able
fitted
to understand. Just go on.
using the hyperparameters that we have here. And the model will pick the two combination that have the highest score. So basically that's how grid search works. So maybe we can implement it. Yes, good evening. Yeah, for the same data. No, same. It's the same data. So it's the same X and Y, but with a different combination of C and alpha. Have you understood that? So X and Y are not changing, but the C hyperparameter. Okay, so here I'm importing grid search CV. So from sklearn.model selection, import grid search CV. Then we are going to import our logistic regression model. So from sklearn.linear model, import logistic regression. So what I'll do is I'll use our C and our penalty. So we will specify the two. So we are going to set the parameter grid. So it's called a parameter grid. So we are going to say let our grid be equal to, and here we are going to create a dictionary. So our dictionary will first have the C values. Those are our C. Then we have the elastic. So we can here we instantiate the model. So we instantiate the model without specifying any hyperparameters here, but you can specify the hyperparameters here if you wanted to. Then after doing that, we instantiate the grid search model. So here we will have grid search being equal to grid search. Then estimator is the logreg. So estimator is the model that we are going to use. Then we specify the parameter grid. So the grid that is going to be used. So the different hyperparameters that are going to be used. And we specify the folds. So CV equals to 5. So this is what we will have. So we will have 5 different splits. And for those 5 different splits, we will have each having these kind of output table. And we can print out the best parameters. So this usually takes a lot of time to run when you are handling large amounts of data, but you can see here it's not fully run. So let me eliminate all the warnings. We can run this again. So here you can see we have our C, the best C being 1.0, and the best penalty being that. So what we can do is we can print the score of each grid. So here you can see grid search dot underscore CV results, you get this. So it's not arranged in a way that you can clearly see it well, but you can see what's happening here. Yeah, maybe I've never tried to like extract these in a table format, but you can see the results are stored in here. But our main interest will be here, getting the best parameters. And after getting the best parameters, we print the score of the best model. So here we type in grid search dot best underscore score, and the best score is at 0.9733. So we can add some other hyperparameters here. So let's see what that we can add. Maybe we can check things like the solver. Then we can check that. So the larger the grid, the more time the model will take to run. And basically that's how you search for like the best hyperparameters. But as I had mentioned to you earlier, so you won't be like doing this on your own when working on maybe large scale models. Because if you decide to like create industry based models, you can go ahead and use models like the CAT Boost model. And in machine learning, we have what we call the auto hyperparameter tuning. Okay. So the automated hyperparameter tuning can do all this work for you, and you won't have like a need of knowing which hyperparameters you are using and maybe how they are applied. Because for me, I believe this is too much noise for you to like try and understand. So what you basically need to know is I can use auto hyperparameter tuners to tune my models, and yeah, I'll be good to go. And basically for models like the cat
Hello,
boost
Joseph.
models, you don't
So we
have
can
a need to
you
like
can
do
scroll
the hyperparameter tuning
up
because the
a little bit
models
down.
tune themselves.
We go back to the grid.
So you can go
Uh,
through these website and see how you can use
view one.
the
I don't know. Oh, you had
cat
not
boost
this
model.
one. The one
Okay.
that you ran
So
earlier.
that's grid search. So you've seen how grid search works. So we have another model
Oh, we are not yet there.
which can be
Because
used
I
and is a
wanted to
little bit
just know how to
fast,
interpret
and
it.
that is the
Because
randomized search.
exactly, I just
So
wanted
the
to know how to
randomized
interpret it.
search,
Because
what it
once you
does
have all
is
that
that it
information, you
ignores
actually need to know
some
that
of
this
the
is what I'm looking for. This is what
hyperparameter
I'm looking for,
combination
and all
here.
that.
It skips some
But if it is
and
automatically
chooses some.
picked
So for example, if we were to
that
do
the
20 fits
best
here,
two or
randomized search
three
would
models
do
that
like
are
10
fitting
instead
properly,
of 20. So it
then
will
maybe there
skip
is no
some
need.
and
But
fit some.
it's also good, to know how to actually interpret your outputs.
So what we can do here is we can instantiate the randomized search. Yes. Yeah, this is the grid part. Yeah, this one. I've added some few more values like the grid search. Yeah. Okay, a minute. So as I was saying, so if I say log reg should be equals to that log reg dot fit xy, then I get the score. The things that I can add in here in our logreg model to like get an improved accuracy. So here you can see our improved accuracy is at 0.98. So let's do that. So we can specify our C to be equal to 1.0, then our Saga. So if we do that and the model, you can see we get an accuracy score of 0.98. But remember, grid search was using some cross validation, so this CV, so some faults here. So the model has a more better accuracy of 0.98 as compared to like doing the fit directly. Yeah. So do you understand the importance of like these hyperparameters that we have in here? Yeah, that's basically what we I'm showing you. Like if you play around with these variables that can be added in here, you can improve the score of your model rather than running the model as it is in plain. Any questions concerning these parts? So if we have no questions, we can proceed and we can look at the randomized search. So for randomized search, you can see this is what we get. And for randomized search, we get different hyperparameters. So if we print the best score, the best score is at 0.98. So it's close to what we have here at grid search. So randomized search is not that better, is not better than the grid search. So grid search is preferred, but grid search takes more time, computation power to like do the search for the best hyperparameters. Yeah, so that's all for these of hyperparameter and grid search. Any questions concerning these?